Hello students, this is a supplemental video to lesson U5A05a, which talked about special right triangles, 30, 60, 90 right triangles, and 45, 45, 90 right triangles. In that video, we used the Pythagorean theorem extensively. And just to be fair, we've used the Pythagorean theorem pretty extensively throughout this course already, but then we never really talked about where it came from or why it even works. So I want to spend a couple minutes just talking about why the Pythagorean theorem works, and this is the proof of that. Here we go. So the Pythagorean theorem states that if I have two legs, okay, and they form a right angle together, okay, the sum of the two legs squared, the sum of the square of the two legs will equal to the hypotenuse squared. Well, why is this even true? Okay, so let's take a look. Okay, what we're going to do is we're going to take a look at this box, okay, that I've built here. And with this box, okay, this box is actually made of 4 congruent right triangles, all of which have side lengths A, B, and C. Okay, so take a moment here to digest that that this is the setup, okay, and that this makes sense, and that this in fact is a square. And just to be clear, this is not the only way of proving the Pythagorean theorem. This is just one way that, for me, sticks out in my mind, that makes the that solidified, at least for me, that the Pythagorean theorem works 100%. Okay, and there's no doubt to it. So let's take a look. All right, do you recognize that this is a square? First off, right? The height and the width, okay, are all the same length. The length is a plus b. And do you see that the 4 right triangles are all congruent? Yes, indeed, right? Because they're going to be congruent because of side, 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 side angle, side, whatever you want to call it. Do you understand why the rhombus inside must be a square? Now, this actually takes a little bit of recognizing, a little bit of just close observation. So if you look at these angles over here that are formed, right? I have 1 tick mark and 2 tick mark. The one in the middle must therefore end up being 90, because if you look at all these triangles here, I have 2 tick mark, 1 tick mark, plus 90 adds up to 180. So therefore, the one in the middle therefore has to be 90. Each of these must be 90 degrees. Okay? All right, so we need to establish this, okay, because we need to make sure that the quadrilateral on the inside is indeed a square. Okay, so now that we have that established, okay, we also recognize the area in pink, therefore, okay, to find the area of the triangle in pink, we're going to multiply the 2 legs and divide by 2. To find the area of the square on the inside, we're going to take C and we're going to square it. So if I were to take all these lengths, or all these areas, and add them up together, okay, or perhaps maybe I can rearrange them, okay, can we all see that these 2 squares, okay, actually have the same areas, right? So the area in pink, okay, has been rearranged, okay, to look like this, okay, they all have the same area. So what are the dimensions of the white square? Of both of these white squares? Okay, so let's take a look. If this is length B here, this must be length A then, right? And we also know that because this is A here, this therefore must be A. And if this is B, this length here is B because this length is B, so therefore this is B. And if this is A, this length must be B because the sum total of the length must be B. Wait a second. So the first white square is A squared, and the second white square must be B squared. And didn't we just establish that the 2 white squares will equal to the total white square? That indeed is the case. So that's why A squared plus B squared must equal to C squared. You have no idea how incredibly useful this is, the Pythagorean theorem. It helps pave the way for so many other fundamental ideas in math, in geometry, and algebra. Okay, so that's pretty much it. That's the theorem. All right.